Okay, so somehow, I don't know, somehow in my notes I had some crazy something there. As I said, I'm a biologist and not a physicist, and I told you some number of calories that equal a joule, and I don't know what it was, but when I looked carefully at it, that what I told you before was wrong. So first thing I want to point out is that 1 calorie equals 4.184 joules. And we had said 1 calorie is the amount of energy that's required to raise 1 cubic centimeter, a tiny little square of water, 1 degree centigrade. And we had said, what is a joule? A joule is the amount of energy that is required to lift 100 grams, 1 meter against gravity. In any case, they are interchangeable, but the conversion that I gave you was wrong. So how do we know this? I mean, how do we know how many calories or joules are in a fuel? Well, there is something called a bomb calorimeter. And basically what it does is it completely combusts a potential fuel, and it captures and measures the amount of energy that is released. We had said you go from a higher energy state to a lower energy state, basically a complex carbon containing molecule to these very simple single carbon containing molecules, carbon dioxide. And then because you went from a higher energy state to a lower energy state, you release energy. And so the calorimeter will give you a measure of the potential energy that is present in a fuel. So what did we say? We had said this is all about how we make energy, and we're talking about things like electricity or driving your car. When I say energy, I don't mean the energy to pick up an apple. I mean, for use in our industrial society. And so when we talk about something like a power plant, we can say we've got this coal and we're going to burn the coal. It's going to release its heat, and then that heat is going to be used to boil water, and then the steam that is produced from the boiling water is going to be used to do work, which is to turn a turbine. And as you turn this turbine, you're going to produce electricity. There's a lot of steps in that, right? And we have a couple of laws of physics that come into play when we talk about all of those steps. The first law of energy is the law of conservation of energy. And it basically says that matter is neither created nor destroyed. It just changes state. So we were talking about that change in the energy state that's present there. And then we have the second law of energy. It's the second law of thermodynamics, and it basically says that the universe is moving towards disorder. And that's a very hard concept to understand, except what it's really saying is you're going from a complex structure to a less complex structure. And so what it means in practical terms, in terms of our example of the power plant having many steps in the process of making electricity, is that with every energy transfer, the release of the coal that is being used to then boil water, you lose some energy. And that's something called entropy. Entropy is the loss of useful energy with every energy transfer. So when you are boiling water, some of the energy that could have gone to exciting water molecules is lost to the environment as heat. So that's the lost energy. And as you know, when you have a pot of teapot, if you put your hand on the side of the teapot when the water is boiling, you'll burn your hand. Why? Because about 90% of the energy is being lost. So there's a major loss of energy, and that's entropy. There's this incredible loss of of energy with every energy transfer. And what is that a result of? It's the second law of thermodynamics. It's called entropy. Okay? Okay, so we'll stop right here and we'll start talking about coal.